Hello everyone. Today's lesson is lesson 9. Goal is review conceptual multiplicative behavior of exponential function. And then number E, the negative exponent. So let's do this one. We have the form exponential function. So f of x equal to c a to the x power, where c is greater than 0 means it's a positive, right? C is positive. A is greater than 0 means A is positive. A cannot be equal to 1. So let me write down. Means, no, this, not C means. This means positive, right? And this means also positive. Okay, we call A is base. This is a base. And this is initial number or starting point. Initial value. Value or start point, right? Okay, so the below one, we have c equal to 1 and then a equal to 2, right? So basically the exponential function 2 to the x power, right? Then let's writing out. Negative 3 we have. That means f of negative 3 equal to 1 times 2 to the negative 3, yeah? Okay, so there will be, we have 1 over 2 to the third power, which is 1 over 8. Negative 2, f of negative 2 means 1 times 2 to the negative 2, which is 1 over 2 squared, equal to 1 over 4. And 0, f over 0 equal to 1 times 2 to the 0 power, which is 1. 1, f of 1 equal to 1 times 2 to the first power, which is 2. 2, f of 2, which is 1 times 2 squared equal to 4. And 3, f of 3 equal to 1 times 2 to the third power, which is 8, right? So we keep doing that, right? Okay, now they ask us every each x increase 1, right? Every time increase 1. So let's talk about the positive first. The positive is more, we can see easily, right? So 2 to the first power 2, 2 to the second power is 4, 2 to the third power is 8. Then what's the y will be? So they ask what's the behavior of y, right? So 2, 4, 8, 16, and what was that? 8. uh, I said 16, right? And then 32, right? Okay. Then what? How can you say that? Why doubles, right? Yeah, why doubles? Spell? Okay, that is good. All right. We have exponential function. So let's take a look. So if we click this one, we get this one. Ta-da-da. Okay, so the first one is the red one. The c equal to 1 and base is 2. 2 to the x power. So we have this one. This one is the right side, right graph here. So exponential function, right? So we had earlier negative 2 means 2 to the negative 2, which is 1 over 2 squared, which is 1 over 4. That is 0.25. -1, 2 to the -1, which is 1 over 2, which is 0.5, right? And then so on. Okay, let's take a look. 3 to the x power, c is the 1, right? So 3, not this one. Oh, accidentally. Okay, undo. Okay, I got it. Okay, next one is black. Black is 3 to the x power here. So that black one, right? So we can have that. All right. Oh, there is E. So let's talk about the E first. E is the number, real number, which is 2.718281, and never finished, right? So it keep going down. We have more digits, decimal places, right? Never end. So we call E is irrational number. So I cannot denote a number here. Maybe after this, let me screenshot and then I'm gonna explain to you more about this one. Let's see. So E is 2.7 roughly, right? So let's say that. Then E is between 2 and 3, right? Because we had base 2 earlier, the red one. And then we have a black one, which is base 3, right? So that black dot is base 3, 3 to the x power. Then this one must be E, base E, this one. Can you see that? The purple between black and red, that is E, because E is real number, which is 2.718281, right? Okay, now, then 1.755 to the x power, which one will be that, right? That is the next to the red, because this red is the 2 to the x power, right? I'm talking about red, right one, right? The positive x quadrant one, right? So 1.75 base, which is this one, another purple, right? They should use a different color. This one is 1.7.5 to the x power. Make sense? Okay, let's talk about the left side, the negative x-axis, right? Which is quadrant 2. So here we have 1 over 2 to the x power. So let me make that. The green is 1 over 2 to the x power. The red one, right side is 2 to the x power. And the green one, left side one is 1 over 2 to the x power, right? And 1 over 3 to the x power is the red one, left side. Can you see that? Okay, then let me screenshot this one. Let's go to the lecture note. And this number. So let me make fireworks outside. Yeah, out. Okay. All right. So paste. Oh, it doesn't work. Let me see a screenshot you see here. Okay, screenshot here. Okay, so everything in the case is C equal to 1, right? So let me write down C equal to 1 here. Um, the black one, red one first. The red one was, this is f of x equal to 2 to the x power, right? And the black one was 3 to the x power, right? Then purple between 2 and 3 base, there will be e to the x power, right? And another purple right one is 1.75, I believe. Let me use this one. F of x equal to 1.75 to the x power, right? Okay, the red one left side was 1 over 2 to the x power. And then green one was the 1 over 3 to the x power, right? Okay, let's move on. The exponential function f of x equal to c a to the x power, where c is greater than 0 and a is greater than 0. A cannot be equal to 1. A is, we call the base. We talked earlier, right? So c is initial point, initial value, initial point, and then also starting point, right? Okay. Also, we say that C is y-intercept. So we know what is the y-intercept means, right? The point on the y-axis, right? Then how do you find y-intercept algebraically? Then set x equal to 0, right? Then the y-intercept, we can express the order pair as 0, C in the case, right? All right. Let's take a look the picture. They say that here, the growth. So exponential form is greater than 1. This form, we say the growth. Like A, like earlier, A equal to 2, 3, 4. Okay, let's take a look. The other one, they say that decay, right? Decay. Look, A is between 0 and 1. And then the graph looks like this. Yeah. We had earlier, when the graph looks like this, 1 over 2 to the x power, 1 over 3 to the x power, right? So A should be the fraction form. So we say that the proper fraction form, proper fraction form is the less than 1, okay? So let me write down. Proper fraction. Think. So 1/2, 1/3, we had that, right? Or we can say that 2/3 or 4/5, anything less than 1, okay? As a fraction form. Okay, now let's answer this one. The number of bacteria being culture is given by BOT equal to 10 4 to the T, right? So C in that case is C, right? C in the case is C. C in the case is 10, right? So this is the form C a to the x power, right? So C is the 10, A is the 4, T is, X is the T, right? Now here, where T is the time in hours, right? Number one, are the number of bacteria increasing or decreasing over time? How do you know? So what do you think? It's increasing, right? Increasing. How do you know? Because A is equal to 4, which is greater than 1, right? They say that this form is increasing, which is growth, right? When A is greater than 1. Now, number 2, how many bacteria are in the culture at time 0, right? So that means when T equal to 0, what's the bacteria there, right? So T equal to 0. So B over T, which is 0, then 10 times 4 to the 0, which is 10, right? Because any power of 0 is 1. This is 1. Okay, number 3, how many after 2 hours? That means T equal to 2. So B over 2 equal to 10 times 4 to the second power. If we calculate, this is 160. Now, how many after 8 hours? That means T equal to 8. B of 8 equal to 10 times 4 to the 8 power. So if we calculate, this is 655,360. Okay, number 5. What does the 4 in the equation tell you? So what do you think about this one? It's a growth, right? We knew that. We talked in number 1, growth. All right, so this exponential growth factor, we call this the growth factor multiplication, right? So growth factor shows how rapidly the quantity, right? So let me write down this exponential growth factor shows how rapidly the quantity of what? So bacteria, right? Spill increase as T increases. Sorry about that. Okay, sketch. So let's sketch. I want to use whatever we have information when T equal to 0, T equal to 2, T equal to 8, right? So when T equal to 0 is 10, well, look the scale. Scale is 50,000. So 10 is very tiny. So let me plot the point here. Very tiny. And then when T equal to 2, we have 160, also tiny, right? Because the first scale is 50,000. When T equal to 2, how about this? Yeah. Okay, now when T equal to 8, we have 655,360. So 8 here, and then 655,000. Yeah, so approximately here. Okay, let's connect like this. Yeah. Ugh, ugly. Sorry about that. Hold on one second. Okay, this is my best drawing. Is it okay to you? All right. Let's do review rules. So we know how to calculate the exponent, right? So 2 to the fourth power means 2 times 2 times 2 times 2, which is 4 times 4, which is 16. 2 times 2 times 2, which is, uh, wait a minute. That's 8, right? And 4, this is 2, and 2 to the 0 power. Any 0 power, we get 1. 2 to the negative 1, which is 1 half. 2 to the negative 2, which is 1 over 2 squared, which is 1 over 4. 2 to the third power, which is 1 over 2 to the third power. That is 1 over 8. 2 to the negative fourth power, which is 1 over 2 to the fourth power, which is 1 over 16. So in general, we have this one, right? Okay, let me explain to you why we have that kind of a formula. We knew that the previously, right? So a to the m times a to the n, we have a to the m plus n, right? A to the m over a to the n, which is a to the m minus n, right? So multiplication, we add their power. Quotient, we subtract their power, right? Now, if we have a to the negative 1, then do you agree we have a to the 0 minus 1? Yes? Okay, subtraction, that means the quotient of the base, right? So it will be a to the 0 power over a to the 1, right? Then we have this one, right? Okay, a to the 0 power, we knew one, right? And then a to the 1 power, which is a, right? Okay, then I can explain this one too. A to the negative 1. I'm sorry, negative a to the negative n. Same concept. We can express a to the 0 minus n. Yeah, there will be a to the 0 power over a to the n, right? There will be 1 over a to the n. Okay, so this is the formula we have. So that means 1 over 3 to the second power. Also, we can express the power like that, right? So 1 squared over 3 squared. 1 squared means just 1 over 3 squared, right? Then we can express as a 3 to the negative 2 because we have this one, right? Same as So 1 over 9 to the x power. This is 1 over 9 to the x power. So we can say that 9 to the negative x power. Reverse, we have a negative exponent. Then we can express this one is 1 over 100 to the x power. That is, we can express 1 over 100 to the x power, right? Okay. Now, 1 over e to the 2t, same as earlier, right? So we can multiply the exponent. So 1 to the 2t over e to the 2t. 1 to the any power is 1, right? And e to the 2t. Then 1 over e to the 2t, we can express as e to the negative 2t, right? All right. Once again, we have exponential decay here. Look, let's take a look. We have c and a to the x power, right? C is greater than 0, a is greater than 1, is growth, right? So like earlier we did that. A equal to 2, 3, 4, right? And so on, right? Here, C is greater than 0. And we have A is between 0 and 1. Means that the proper fraction, right? So 1/2. 1/2, 2/3, anything, right? Okay. Now, this is also decay. Can you see that? This one? But in that case, A is greater than 1. Look, what's the difference with here, right? So this is a positive, this is a negative, right? A is greater than 1, A is greater than 1 as well, right? So if we express A is 1, 2, so A is 2, 3, 4. So if we express, let's say that C equal to 1, right? 2 to the negative x, yeah. That means we can express 1 over 2 to the x power. That is 1 over 2 to the x power. So basically, this one, same function, but different format, right? Same. That's why they have a decay together, right? Any question? Oh, you can ask me. Keep saying that. Okay. Thank you for watching. Bye.